In this video, we're going to be doing two things: finding the prime factorization of 600 using a factor tree, and then afterwards asking ourselves how many factors does 600 have? Not just the prime factors, all the factors. So to do our factor tree, we just need to find two numbers that multiply together to give us 600, and we can use whatever we'd like. Here, the obvious choice for me might be to choose 6 and 100. That 600 is 6 times 100, and both of those numbers are composite. 6 is composite, as is 100, which means I still have some more work to do. 6 can be split up into 2 times 3, and both of those happen to be prime numbers, so I'll just put a little box around those to remind me that I need to stop at that part of the tree. For 100, I could write that as 10 times 10, and of course 10 and 10 are both composite numbers, so we can go further. 10 could be split into 2 times 5, and the other 10 also could be split into 2 times 5, and 2 and 5 are both prime numbers, so we have no further work to do. We've split up 600 into all of its prime components. So 600 we could write as, we have 1, 2, 3 2's, or 2 to the power of 3. We have 1 3, and we have 2 5's. So my prime factorization of 600 is 2 to the power of 3 times 3 to the power of 1 times 5 squared. And it doesn't really matter how I might have began with my factor tree. I might have, for example, started with 2 and 300 rather than 6 and 100. It really won't matter, because by the unique factorization theorem, the fundamental theorem of arithmetic, I'll always end up with the same prime factorization. Now, as far as how many factors do we have, we know which are the prime factors. There's 2's and 3's and 5's, but there's lots of composite numbers that go into 600. For example, 60 or 30 or 10. What we want to know is how many factors are there in total. And one thing that we know is any factor of 600 must be made only out of 2's and or 3's and or 5's. We can have up to 3 2's in any factor of 600. We can have up to 1 3 in any factor of 600. And we can have up to 2 5's in any factor of 600. So if we're thinking about the number of factors, we actually have 3 little tasks to settle on, which is how many 2's, how many 3's, and how many 5's are we going to have in our factor. For 2's, there's 4 choices. You could have no 2's, or 1 2, or 2 2's, or all 3 2's. We have 4 possible choices for how many 2's there might be in any factor of 600. For 3's, there's 2 choices. Either you do have a 3 or you don't have a 3. None of them or one of them. So there are 2 choices for the number of 3's. For the number of 5's, there are 3 choices. We could have none of the 5's, or one of the 5's, or all 2 of the 5's. There are 3 choices in total. So by the fundamental counting principle, since there are 4 ways to figure out how many 2's we might have, 2 ways to decide how many 3's we might have, and 3 ways to decide how many 5's we might have, there should be 4 times 2 times 3. There should be 24 possible different factors of 600.